Good morning. I'm Dr. Navina Priyadarshini, Professor of EC Department, and today's class we shall discuss about the ionospheric characteristics of satellite communication. So the ionosphere is the part of Earth's uppermost atmosphere. So its ranges from 80 to 600 kilometer, where the extreme ultraviolet rays and the X-rays of solar radiation and ionizes the atoms and molecules, thus creating the layers of an electrons. So the ionosphere is important because it reflects and modifies the radio waves used for communication and navigation. So ionized part of the Earth's atmosphere is known as ionosphere. So the ultraviolet signals from the sun collides with the atoms in this region and make the electrons to be free or loose. So this is because of that the ionosphere is named, and it is the free electrons that cause the reflection of and the absorption of the radio waves. So it happens when the atoms and molecules in the upper atmosphere excited by sunlight emit light to shed their excess energy. Or it can happen when atoms and molecules that have been ionized by sun collide with the capture a free electron. So the different layers or regions that ionosphere have different characteristics and affect the radio communications in different ways. There are also differences in exact way they are created and sustained. So there are various regions of ionospheres are there. So they are named as D region, E region, as well as F region. And first of all, we shall discuss about we can discuss all these regions. So first, we shall discuss this D region. So D region is one of the part of the ionosphere. So when a sky wave which leaves the Earth's surface and travels towards upward, the first region of interest is that reaches the ionosphere is called D region. So this D region is also named as the D layer. So the first layer of this ionosphere is D region. So in this D region that will present at the height or altitude of around 60 to 90 kilometers. So from the Earth's surface or its surface, it's of around 60 to 90 kilometers is the ionosphere's D region. And the radiation within it's only present during the day to an extent and affects the radio waves noticeably. So it is sustained by the radiation from the sun, and levels of ionization falls rapidly at dusk when the source of radiation is removed. So the D layer, which is the generated by the action of a form of radiation known as Lyman radiation. So here this radiation whose wavelength is of around 1215 Armstrong, and the ionizes which this radiation which ionizes the nitric oxide gas present in the atmosphere. So in this D region the atmosphere consists of number of gases. So it takes the reactions in the nitric oxide gas present in the atmosphere. So next, the X-rays also contributes the ionization. So we shall discuss it. So the hard X-rays also contribute to the ionization, which especially towards the peak of the solar cycle. The D layer, which mainly has the effects of absorbing or the attenuating the radio communication signal, particularly in the low frequency range as well as the medium frequency range portions of the radio spectrum. So here when the signals are radiated in this low frequency as well as medium spectrum that are highly absorbed, and at night it has little effects on most radio communication signals, although there is still a sufficient level of ionization for its refract uh, very low frequency signals. So the level of attenuation which depends upon the frequency. So the low frequencies are attenuated more than the higher ones. So therefore the attenuation is the inverse of the square of the frequency. So where k is the constant and frequency is indicated in hertz. The D region attenuates signals because of the radio signals cause free electrons in the regions to vibrate. So as these signals are get vibrated, the electrons collides with the molecules, and each collision there is a small amount of loss of energy. The amount of loss of signal energy which depends upon the number of factors. One is the gas molecules present in that. Then the greater the number of gas molecules, higher the number of collisions and higher the range of attenuation. So the level of ionization is also a very important parameter. The higher the level of ionization, greater the number of electrons that vibrate and collide with the molecules. The third major factor of frequency is the frequency of the signal. As the frequency increases, the wavelength of the vibration shortens and the number of collisions between the free electrons and the gas molecules also decreases. As a result, signals lower in radio frequency spectrum are attenuated higher or far more than the higher the frequencies. Next region is the E region. So E region or named as E layer, it is above the D region. It ranges from 100 to 125 kilometers. Here also the ionization results from the number of types of radiation. So here the soft X-rays produces much of the ionization which are due to the extremely high ultraviolet rays uh, plays an important role for this ionization. So here the radiation produced in these ionizations whose wavelengths are ranges from 10 to 100 angstroms, and the degrees to which all constitutes contribute depends upon the state of the sun as well as latitude at which observations are made. Next region is the F region, the most important region in the ionosphere for long distance high frequency radio communication takes place in the F region. During the daytime, when the radiation is being received from the sun, it often splits into two. One is the lower region, lower F region, that is F1, and the higher one is the F2 region. F1 region is more of an inflection point in the electron density curve and generally only exists in the summer. And typically, the F1 layer is found around the altitude of 300 kilometers, and F2 layers is in the altitude of 400 kilometers. So here the altitude of all the layers in the ionosphere varies considerably and the F layer varies the most, and the F layer acts as the reflector of the signal in the high frequency portions of the radio spectrum, enabling the worldwide communications to be established. So it is a major region associated with the high frequency signal propagation, so by which in this ionosphere region the radio frequency signals are get communicated. Thank you.